In the previous classes, we are seeing the concept of process, right? Various things about the process. Later, we discussed how we make the process into the running state by learning various kind of CPU scheduling algorithms, right? So once a process is in running state, suppose for example, if I say process P1 is in running state, at some point of time definitely it will comes out and all the information about the process is going to be maintained in PCB, process control block, right? Later part, one more process is entered into the CPU and assume that it comes out, right? Process P2, it's having some process control block. Meanwhile, some other process will enter and will try to work with accordingly, right? So when a particular process is executing, there might be a chance or there might be a situation where one process wants to communicate with other process. Like for example, if I say counter is a kind of variable which is contains certain data where process 1 is using and process 2 is also using. Is this possible? Yes. Means when multiple processes are communicated, there might be a need of sharing of data. Sharing of data, right? At that particular situation, you might encounter two situations. One will be they are cooperate to each other. They are cooperate each other, and another kind will be competitive each other. Is this possible? Is this sentence are understood or not? For example, let's say you are outside of the door. I am asked you to enter into the classroom, right? What you all will do? You all will cooperate among each other and will come in line by line. That is what you can generally call it as cooperative. Or the other chance will be all people will fight each other and will try to come into the class. That is what we call it as competitive, right? So means when a communication is going to be done between the two processes or between the n processes, the communication can be done in two ways. One will be cooperative process or in the form of competitive manner, right? Means if you take this particular example, simple, first P1 completes task, then the output which is produced by the P1 will be used by P2. This is what I can call it as cooperation. Or what will happen? I may agree that first you can complete, like P2 will complete, then P1 will complete its task. We can call it as cooperative, right? What is the meaning of competitive? Something like if I am having a shared resource, something like printer. I am requesting the printer to print it, and there will be another process which is requesting at the same time. Both are fighting each other to make print something, right? At that situation, what might be you observe? Can you get the printing in zigzag order? If I am going to compete both of at the same time, right? So which means that you might get some incorrect data. I mean, let's say with a more technical example, there will be a lines of code which is related to the process P1, and I am going to have certain common data, something like count equal to count plus 1, and there will be a huge lines of code. And there is a process which is P2 which is executing some lines of code on the data called count equal to count minus 1, count equal to count minus 1, right? In general, if you are going to write any kind of set of statements, how this count equal to count plus 1 will behave is, internally it will be converted into what? Low level language, right? So I can say this is a kind of high level language. It will be converted into low level language. Before that, we are going to write various kind of assembly level language also, right? So how can you write this in terms of assembly level language? Can I write load load count variable into a register called R1 register. You know, for every process P1, you are going to maintain certain kind of general purpose registers, right? So general purpose registers will store the data and also will store the state of every information, right? So as this count is a kind of common variable that is shared by everyone, assume that it contains the data as 3, right? First initially what I will do, I will try to load the value which is there in the count variable into the local register R1, and then I will perform increment the result what is available in the R1, and then once again I will load R1 into the count variable, right? These instructions will be simply written in one line if you go with the high level language code, right? So I can given the naming convention as 1, 2, 3, right? Similarly, how can we write this one? If I say first one, load count variable into, let me check the process related to P2 as R2, and you are trying to perform here decrement R2, and then you are performing load R2 into count variable. Okay, fine. Now in this particular situation, assume process P1 and P2 are communicating via cooperative manner, means some agreement manner, which means that what, either P1 completes first, then P2 will complete, right? If it happens like that, what will happen? Assume just P1 is working on the line number 1. When P1 is working on the line number 1, it is going to have a register R1. Now R1 contains what value? 3, right? Good. Next, after completing line 1, line 2 is going to be executed. When line 2 is going to be executed, R1 is going to increment it. If it is incremented, it will increment by what? 4, right? Next, line 3 is going to be executed. When line 3 is executed, the value of R1 loaded into count means what? In the global location is going to be updated, right? So that is what the P1. As P1 is completed its task, I will give a chance to P2 because it's a kind of agreement. Now P2 also done first statement. When it is done first statement, now R2 contains what value? 4, because it is trying to take it from the count variable 4. Now next statement, decrement it by 1, that is 3. Next statement, R2 will be updated into the here, right? So finally, if you try to print the value of count variable, you are going to get the value 3. Is this the correct value? Yes or no? Yes. What I did, I performed one time increment on the number 3 and I performed one time decrement on the number 3 on the count variable. So finally you got the 3 or not? Yes. I think this is the correct one. Am I right? Yes. So which means you are going to get correct data here. Assume that P2 starts execution first, then P1 starts execution. Then what will be the situation? P2 executes the line number 1, line number 2, line number 3. When executes the line number 1, assume that count variable contains the value 3. When executes the line number 1, R2 register contains what value? 3, decremented by 1, that is 2, then updated in the count variable, that is 2. Okay. Next, P1 got the chance, 1, 2, 3 executed, and R1 contains what value now? 2, incremented by 1, 3, right? That will update on the again count variable, which will be 3, right? Finally, you got the data 3, right? Which means it is again a correct data. What is the meaning of this one? With this explanation, I can say that when two processes are cooperative with each other, definitely you are going to get always the same data, and that too it will be a kind of correct data. But if you take this situation where competition is going to be done, where like among the process competition may be happen, right? At that situation, what will happen? Try to observe. So competition means what? In general, even if you go with any kind of multi-programming environment, how many processes are going to execute in a CPU? Only one process. At a particular stage, only one process is going to be executed in a CPU, right? So in cooperative manner, how processes are going to be executed? In non-preemptive manner, they are going to be executed. Means once I get a chance, I will complete my task, then only I will give chance to the another one. Whereas coming to competitive environment, it will be kind of preemptive process. Means once I get a chance, if any process requests for the service, it will give chance to the other process, right? Which means that what? There might be a situation where the process preempts its execution after the line 1 and given chance to P2, yes, or at line 2 preempt and given chance to P2, or something like if P2 is executing. So which means that there might be a situation where at these lines preemption might happen. Then at that situation, how the system is going to behave? Try to observe. If I am trying to execute the process 1 and count variable will be assume as 3, right? If it is executing line 1, local register R1 created. Now R1 contains what data? 3, because count variable is loaded into R1. Count value is 3. 3 will be loaded into R1. Good. Next, it will execute the next statement 2 when it is incrementing the value of R1, that will be updated as what? 4. Now assume that it has preempted here. Means after execution of statement 1 and statement 2, it has preempted. Now given chance to which one? P2. Now P2 is executing the first statement and it contains what value? R2. Now R2 contains what is the value? 3 or 4? 3. It is because what is the value of count? 3. 3 will be updated in the R2. Right? So you may get confusion, why not 4? 4 is not updated because it is updated in the local register. If you want to update in the global register, that should have to execute the line number 3. Right? So P2 done with the first statement and second statement is also done. So it will be done with 2. And assume that it has continued its execution, line number 3. Then what will happen? Here it will update with what value? 2. So load of R2 comma count. Right? Now, if P1 got the chance, P1 will execute what statement? Third statement. Third statement is what? Load of R1 comma count, which means what value it is going to be updated? 4. Right? Which means after completion of execution of P1 and P2 in competitive manner, what is the result you got? 4. Is this the correct one? No. We did one time increment, one time decrement. Again I have to get the same result only. But you got here as 4. Which means what? Incorrect data. I can say it as data inconsistency. Data inconsistency, right? This is not the only case. Suppose for example, if I say P1 executing line number 1, what is the register value? R1 contains the value 3. Assume again I am taking the count as 3. R3, right? Now it has executed state number 2. When it executes the state number 2, it will increment it by 1, that is 4. Done. And preempted it is. It is preempted. Now given chance to P2, it is executing state number 1 and statement number 2, which means again locally created with the R2, which contains what value? 3, and decremented by 1, which will be 2. Now assume it is preempted. It is preempted. When it is preempted and again given the chance to, suppose for example P1, statement number 3 is going to be executed. What is statement number 3? Loading R1 into count. What is the R1 value? 4. 4 will be updated to here. And as it does its task, given chance to P2. And third statement is executed, Right? Third statement is what? Loading R2 into count value. What is R2 contains? 2. 2 will be operated to which one? Count. Right? Which means after completion of P1 and P2 process, what is the result you are getting? 2. Again, even you are performing one time increment or one time decrement, if you want, you are getting actually 3 value, but here in this particular processor you are getting the value 2, which is nothing but again incorrect data. I can say it as data inconsistency. Right? Not only this way, you can able to do it other way also. There might be a chance to get incorrect data. Right? I am not saying that always you are going to get incorrect data. There might be a situation where you might get incorrect data. So that is the reason I am showing these two cases for you. Which means when you are going to execute the instructions, these instructions P1 and P2 in a concurrent manner, in a competitive manner, you are getting 3 types of results. One will be 2 is one time you got, another time you got 3, another time you got 4. Right? So you can't guess what is the correct result. Right? This kind of thing we can call it as race condition. Race condition, right? Whoever are running first in the race, they will win first, right? So on whatever the order the instructions are going to be executed, right? I can say that the order in which instructions are going to be executed, the result is going to be depend. The result is going to be depend. Am I right or not? Because so as here the instructions are executed P1 1 2, P2 1 2 3, P1 3, you got the 4 as answer. In this particular situation, P1 1 2, P2 1 2, P1 3, P2 3, you got the result as 2. Here the case is P1 is completing executing 1 2 3 instructions directly, P2 is executing instructions 1 2 3 directly. That's the reason you got the result as 3. Right? Based on the order in which you are executing the instructions, your result is going to be depend. This kind of condition we call it as race condition. Right? So when you are executing multiple instructions in different orders, if you get different results, we can call it as data inconsistency. You can see, and this will lead to, we can call it as race condition. Right? So this kind of situations we need to handle. How we can handle this means that we'll see with respect to various kind of synchronization algorithms. Which means that when you observe any kind of race condition, definitely you are going to get incorrect results. How we are going to overcome the race condition? By implementing various kind of synchronization algorithms. Right? So because of lack of synchronization, what is one kind of problem you are going to observe? Data inconsistency is one kind of problem you can observe. Okay, and another kind of problem is loss of data, and the another kind of problem will be deadlock. These are the 3 things that we can observe when you lack with synchronization in the programming.